so this is on page, it's notes 3.5, which is a huge section. The back of page 29, number 5. These are the last few problems. And here we go. Any ideas on how we should do this one? It's kind of an easy one. I think we should know. What's our very favorite thing to do? Loop-de-loo. So we're going to say 3 to the second equals 5x plus 7. 3 to the second is 9. And then we'll just solve like a regular equation. So we'll subtract 7 and divide by 5. So I got 2/5. Easy enough. The next one has a complication in it. Does anybody see what the issue is here? 2 logs. We don't want 2 logs. We can't have 2 logs. Not allowed to have 2 logs on the same side of the equation. So somehow we have to put those together. We learned how to do that a few days ago. When that's a plus, if I want to put them together, what am I going to do with them? If it's a plus? Multiply. So I'm going to put this together as one logarithm. So instead of having 2, it's going to go together as 1. And these things are going to get multiplied. Because that is a plus. Okay? Now, what is x times x minus 3? X squared minus 3x. Does it look kind of like this one now? I think it does. So what do you think we're going to do? Loop-de-loo, using a base of 10. So 10 to the first equals x squared minus 3x. What's 10 to the first? 10. What do you think I'm going to do with that now? Think you know this. It's a quadratic equation. Yep. Ceres is over there going like this. We're going to get that 10 moved over. So we're going to have 0 equals x squared minus 3x minus 10. And then what am I going to do? Quadratic. I can either use the quadratic formula, or this one does factor. So if you can see how it factors and you want to factor it, that's great. If you don't see how it factors, then use the quadratic formula. At any rate, we're going to get 2 answers, and what are those answers going to be? 5 and negative 2. Now, just when you thought, okay, we made it through this big problem, we aren't done. It turns out that that answer is extraneous. And the reason it's extraneous goes back to something that we observed when we were typing things in on our calculator. Remember, sometimes we typed it in and it said error. When did it say error? When you typed in the log of a negative? Remember that, guys? We did that. So when you press log of a negative, it says no can do. So I want you to look at that answer in the original problem. Could I put a negative 2 in here? Could I do the log of negative 2? No. So that's an extraneous root, and I have to throw it out. You can't ever take the log of a negative. Ever. So the fact that I got a negative there means I have to get rid of it, and the only answer to the problem is pi. There's a lot. There's a lot in that problem. I get it, but gotta figure it out. All right, let's do the next one, see if we can put all these pieces together. this is very, very similar. What do you think we're going to do first? Very, very similar problem. Multiply. We're going to put them together. We're still going to have a logarithm. Don't drop the logarithm. You just have one. You're squeezing these together into one. And what's going to be in here then?
X parentheses.
This times this. So if you want to go ahead and write x squared plus 3x, that's fine. If you want to write x times x plus 3 for your first step, that's fine. When you squeeze those logarithms together, because of the plus, it's a times. If that had been a minus, it would be a divide. Alright, so now what? Loop-de-loo with a base of 10. So 10 to the first equals x squared plus 3x. Right? Just like the last one. Now what? Subtract the 10. And either use the quadratic formula or factor. And what are our answers this time? Our answers are -5 and 2, except what? Just like before, we're going to have to get rid of the -5 because we can't take the log of it. Alright, go ahead and cross D off. D involves a bunch of yicky arithmetic. I don't want to take any time to do it, so go ahead and cross that one off. And we're going to go to E. Now, my thought is that everybody in the room should be able to start this problem. So take a minute, do the first step, and then keep going if you can. But the first step is to condense into one logarithm. So you somehow have to put all this together into one logarithm. So in other words, you're figuring out what's going to go in that parentheses when I squeeze it all together. What do you think? Anybody figured it out? What'd you put in here?
X squared minus 16.
X squared minus 16 is, Willow's nodding. How's come it's x squared minus 16? Because we're multiplying our x plus 4 and our x minus 4. And when we FOIL that together, we got this. Okay, now what? Now we loop-de-loo. So 5 to the second equals x squared minus 16. Yep.
So noticing that that's a difference of squares, you don't worry about that yet?
This is the difference of squares?
Yeah.
No, because that's how I got it. Remember, it
you're
started
right.
out that way, and I
got
put it together and then got this.
Right.
Okay, now what? What do you want to do here? What's 5 squared? 25. Okay, how do we solve that? Add 16. So 41 equals x squared.
Squared.
Right, if we add 16. And then what?
Square root.
Square root. So x equals, here's another one, technically plus or minus root 41, because remember we did plus or minus, but I can't use the -1 So I'm gonna get rid of that, and the only answer is root 41. If I use the negative, the square root of 41 is like 6 point something. So if I use negative 6 minus 4, this would be negative 10. I can't take the log of negative 10. You see what I'm saying? It ain't gonna work. So I gotta get rid of that negative, and the only answer is the square root of 41. My F got cut off, so I'm just gonna make something up there. I don't know what's supposed to be over there. I got the log base 3 of x plus the log base 3 of 4 equal to the log base 3 of, I'll say, x plus 5, I don't know. Okay, I just made that up because I can't tell what it is. All right? Wow. This one looks different. But the rules are still the same. You can't have two logarithms on the same side. It's just like here. You couldn't do this problem. You had to squeeze those together. So the first thing you're going to do is squeeze these two together. They're on the same side. So you squeeze these together and make it log base 3 of what?
Okay.
What goes in here? Not x plus 4. When I put them together, when they're added, they go together as a multiply, remember? Guys, that's critical. If the logarithms are added, when you put them together, it becomes a multiply, just like it did over here. Okay? No. Never. Now, take a look at our situation. It's different than over here. Over here, we were able to loop-de-loop. We are not able to do that this time because this isn't a number. This problem's even easier. Think about it. If the log of this equals the log of this, doesn't it make sense that 4x has to equal x plus 5? Doesn't it make sense that these two things have to be the same? It's just like with our exponents. When we had 3 to the x equals 3 to the 5th, didn't we just go straight to x equals 5? It's exactly the same concept. These match, so we don't have to pay any attention to them anymore. We just look at the other part of the problem. So 4x equals x plus 5, and then we just solve. So 3x equals 5, and x equals 5/3. I subtract x from both sides and divide by 3. Can I keep that answer? Yeah, because it's positive, and when I take the logarithm of it, it's going to be fine. It's going to be some decimal, that's fine. So that's my answer. No extraneous roots there. All right, are you looking at the next one, I hope? What's the first thing that's going to need your attention? Can't have it. They got to be combined. So it's going to be log base 7 of something equals log base 7 of 5. That one's okay. There's only one of them. It's fine. These two have to be put together. What's going to go in that parentheses? 2x over 3. Very good, Cam. Why did he do a division this time? Because that's a subtraction. Now, what do you notice? Log base 7, log base 7. Good news, that means 2x over 3 equals 5. 2x equals 15, and x equals 15 halves. Good. One more. Can you give this one a shot? Can you get started on it? This one's base 13. The base makes no difference. As long as they all match, we don't care what they are. And I promise they're always going to match for you. You don't have to worry about that. What did you put in here? 3 over x? 3 over x? And then what did you do? 3 over x equals 12, because these were exactly the same. Now, you guys, don't be canceling out the logarithms in the beginning of the problem. You can only cancel them out when you have log equals log, 1 equals 1. Okay? So the first step has to be to put these together. And then you can drop them out. So 3 equals 12x, and x equals 3/12, which is the same as 1/4. All right, so we got two kinds of problems in this last section here that we just looked at. We had problems that when we simplified them, they looked like this. And then we had problems that when we simplified them, they looked like this. What do you do when you have that situation? Our favorite thing, that's a loop-de-loo, right? What do you do when you have this situation? Drop these out and solve the resulting equation. So, every time you do one of these equations, after you push things together, you're either going to have one logarithm, in which case you're going to loop-de-loo, or you're going to have one on each side, in which case you're going to drop them out. That's what always happens.
What would be on the other side of the changes or
Hmm?
something?
13 squared equals x. Okay? All right. Now, let's look at 3.6. To do 3.6, we need a couple of formulas. So I need you to write these down at the top of your page. You will not need to memorize these formulas. I will give them to you. So on test day, I'll have them written on the board, or they'll be written on your test paper, one or the other. But you have to know how to use them, all right? So up here at the top, we're gonna write two formulas. The first one, and then I'm gonna tell you what all these different letters mean. And again, you don't need to memorize it, but you need to know how to use it. And then the other one, this formula is for compound interest. You know what that is. How many of you have some kind of bank account?
Mm-hmm.
Yep. And hopefully you're getting some kind of interest. It's probably very low because the interest is low right now, but you're getting some kind of interest on it, right? Yeah. And when it says it's compounded, maybe you're getting that interest every month, compounded monthly, and that means the bank gives you a little bit of money for whatever you have in the account that month. And then the next month, you get interest not only on your money, but on the money they already gave you, and it just keeps growing and growing and growing, compound interest. That's this formula. This one is continuous growth. So both of these formulas involve things growing, but this one is for all kinds of continuous growth, not just money. This formula is only money. This one will be used, we're going to do some problems with bacteria populations. They'll be growing. We can also use this formula for radioactive decay, because decay is just negative growth. So this formula is going to work with everything that isn't money. We'll also use it for money if the problem literally says your interest is compounded continuously. If you see this word, that's your formula. If it's not money, that's your formula. Okay? All right, let's talk about what all these things mean. In both formulas, A is the ending amount, what you end up with. In both formulas, that is the end amount. In both formulas, P is the start amount. The P actually stands for principal. That's how much money you put into the bank to start with. That is a 1. It's not an L, it doesn't have any special meaning, it's a 1. This is your interest rate, whatever rate your bank is giving you, but it has to go in as a decimal. So if the interest rate is 5%, then you put in 0.05. Put in the decimal value of the percent. We have 2 N's, and they are the same. Anytime you have a formula, if the same letter is in there twice, it has the same meaning. N is the number of times per year that you compound. So, if your bank compounds monthly, then N would be 12. If your bank compounds weekly, then N would be 52. It's the number of times a year. And then T is the number of years. Now, in the continuous growth formula, we already talked about, here's the end, here's the start. That's E. That's our Euler's constant, that's E. That's not a variable, that is the number E, which is on our calculator. We're going to use calculator for all this stuff. R is the interest rate, or the rate of growth, depending on what our situation is. And again, it's got to go in as a decimal. And T is time. In this formula, it doesn't have to be years. It will tell you in the problem, days or months or weeks or whatever, but it's whatever the time is. In this formula, time is always in years. Okay? okay? Nope, no packing up. We got one, I wanna look at number one. I want you to read problem number one and tell me which formula I'm going to use for problem number one in 3.6. I'm using that one, right? So right now, I want you to copy it down. And we're gonna stick some numbers in. We'll have to wait and solve it tomorrow. Let's stick some numbers in. Where are you gonna put the 1,000? In for P, because that's what I'm starting with, right? What am I gonna put in for my end amount? Read the problem. 2,000. Why am I putting in 2,000 for my end amount? Because I'm doubling my money. It's doubling. So then I have my 1. What's my interest rate? 0.025? What am I dividing by? Quarterly.
God bless.
There's your equation. Quarterly means 4 times a year. And then tomorrow we're gonna solve that. That's gonna be fun. Make sure you have your calculator warmed up and ready to go. If they're not charged, get them charged.